the abstracts you will find solutions as well, which is quite convenient with 10 years of Inspire and Progress, that we not only have challenges but already answers. The presentations are from 3 different countries, 2 from France, 2 from Germany, so the 2 host countries, and 1 from Switzerland, which reminds us that Inspire is not only for the members of the European community, but also for some countries outside of the European Union. We will start with France. Bienvenue, Richard Mittoncher.
Merci. Thank you.
Your floor.
Ça commence mal. I'm sorry. Okay. Oui. Okay. Thank you very much. Okay. COVADIS is the name of our national commission that produce national French standards to be used by local governmental services. It is born in 2009, and its history is very linked with Inspire. But until now, our standards are only concerned with compatibility issue and not yet conformity. Okay. Okay. At the same time, a large amount of local data has been produced and exchanged. And now it's time to prove that COVADIS compliant data can also become Inspire compliant. We will use the wind energy theme to illustrate our presentation, first introducing our wind energy extensions, and then following the alignment of existing spatial data sets. Okay. Well, as a reminder, the French administrative subdivision looks quite complex, but probably no more than in other countries. We have metropolitan regions, as well as overseas regions, not shown here. And metropolitan regions are divided into communes and intercommunal structures. Intermediate local authorities called departments, and very big territorial collectivities called regions. There are other institutions that also produce national standards. So COVADIS is mainly concerned with Inspire teams, but excluding some concerns like water and so on. Okay. The COVADIS productions mainly concerns the deconcentrated services of our national governments, but keep also in mind that all datasets producers and users are first local. Our main role is first to achieve a consensus between EU directives, existing information systems, national objectives, and of course local needs, we want to be pragmatic, to be sure that our operational data structure can be produced and ready to use. But depending on local needs, our geostandards, this is the name of our productions, can also be enriched, so they are extensible. But until now, we only had the issue of compatibility and not yet conformity. Okay. Let's look at geostandard content. 3 parts until now. First, part A, to give information to the end user with 2 main questions. Is it relevant to its needs? How was it developed? Then part B, it deals only with thematic concepts. For example, it details the conceptual model as well as the data catalog. So all of this here is Inspire compatible. And finally, which is quite maybe original compared to other countries, part C, that can be seen as a very useful implementation of part B concepts, thus explaining some kind of recommendations about exchanging or storing the data. However, it's now time for our national standards to evolve from compatibility to better Inspire, but keeping in mind 3 main constraints. All described and implemented concepts, catalog and dictionaries, are French localized. We also have to handle all existing standards and data. And finally, we have to keep the great majority of existing fields in order to produce rich models. Our solution is based on introducing national Inspire extensions and tooling existing data. So we will look at a case study, which is quite simple and just enough complicated, just enough complex, sorry. The theme of wind energy. Why complex? Why complexity? Because you have 2 annex concerns. First, production facilities in order to describe wind turbines and wind farms, but also area management features, because at the regional level, in France, we describe some kind of objects that you can see in the small picture on the right, sorry, which is a wind regional schema, sorry, where you describe all administrative issue regarding wind energy. Let's look at the first extension derived from 3.8 Annex Production and Industrial Facilities. On the left part of the UML model, you can see the 2 main features of the PF, the production installation, here, grouped within the production facilities. So this is the model derived from Inspire. And on the right part, you can see the extension with the wind turbines and the wind farms derived from installation and facilities. So extension model is quite easy. And of course, you keep Inspire conformity because you just extend the model. Okay. You can also see that the features are also enriched with mandatory attributes as well as voidable attributes, such as, for example, the nominal power, which is quite mandatory for wind turbine, as well as the rotor diameter, which is voidable. The second extension for 3.11 area management isn't really enriched, since we can find all in Inspire all relevant attributes describing a wind regional schema feature. So it's quite easy to describe. If you look at the existing physical model of wind energy, let's say the structure of existing shapefiles or PostGIS tables, you can also see how we can reverse map such data back to the corresponding features at the conceptual level, from wind turbine, wind farm, and wind regional scheme. To do that, among other possible transformation solutions, we used RStudio to map existing data back to GML data schema. And as usual, we use shape change to produce the schema from UML model. Such tools are now common for Inspire, but the real improvement is that now our standards include all the necessary mapping information to transform COVADIS Part C compliant data to national Inspire extension. For example, you can see a part of such rules between a wind turbine feature on the left and the corresponding table from original COVADIS implementation on the right. This is another view of the same thing, but using R. Now, if we look at the results, you can see by means of QGIS the transformed GML data of the original datasets from part of the French region, Pays de la Loire. So you have a description of wind turbine as punctual data and surfacic data like wind farm, and also wind regional scheme that describe the two extensions. Okay. As a conclusion, it's now clear that we can still keep our pragmatic methodology with an implementation issue and also adapt our standards to include Inspire extensions as well as the mapping rules. We also demonstrated the capacity to produce compliant GML from existing localized datasets. However, we still have to verify that such theoretical compliance at the standard level can be achieved with all existing data. Thank you very much.
Thank you, Richard, in particular for keeping the time perfectly. There is time for one or two questions. So allow me one question. You have used wind energy as an example.
Yeah.
How much are your standards already developed to cover different issues? Are you just at the beginning, or is it already a greater exercise?
Okay, it's always a difficulty to handle existing data as well as new produced data. So we include the methodology for all new standards, of course, but for existing standards, fortunately, we add compatibility included, but not mapped really So we just have to perform the mapping, and it's not a so big task to do that. But I think the real issue is to verify that, of course, we can prove compliance more perhaps than producing the mapping itself. I don't see the mapping as a real time-consuming task because we have we have process very linked to the UML model, and it's quite easy to transform the data between with the right tools. So.
Good to hear that it's easy.
Yeah.
It's not a common term with Inspire.
Okay.
So good luck.
Thank you very much.
And we. Can you please start the next presentation? We welcome the next speaker. It's from Germany, Holger Heidrich-Wiske, and he is employed with the Federal Statistical Office of the German Republic at Wiesbaden.
Thank you, Mr. Ehlert, for the friendly introduction. Ladies and gentlemen, good afternoon to you all, and welcome to my presentation, Supplying Inspire Compliant Data and Services, the generic solution by the official statistics of Germany for regional data. Okay. At the beginning, 2 slides about the Federal Statistical Office of Germany. The FSO is located at 3 sites, Berlin, Bonn, and Wiesbaden. I work as an GIS expert in the IT department at our headquarters in Wiesbaden. In the European context, the FSO of Germany acts as the national coordinator of the ESS, the European Statistical System. Besides the 14 statistical offices of the German Länder, there are almost 20 other producers for the European Statistical System. For example, the Employment Agency, to name at least one. In spite of the title of my presentation, allow me please to start with an exception of the generic solution. For only 4 years now, the official statistics of Germany is allowed to analyze data and to publish results related to grids. There were no appropriate legal framework conditions before. Thus, I think it's worth to mention that nowadays the grid maps of the Census Atlas 2011 are provided Inspire compliant. I will quickly go through some slides I prepared about this issue. Let's have a look at the view service. On this slide, visualized by in the viewer of the Geo portal hosted by the German SDI. The functionality for downloading may be more interesting. The download services are realized as predefined atoms, and at the same time, this is an example of making Inspire compliant data available by an open data portal. Downloaded data can immediately be used with full functionality of spatial analysis tools provided by GIS software. And this is, of course, an example after zooming into the map. But now let's turn to the actual point of my speech. the generic solution for regional data. The whole thing started with one statement, with one general statement: official statistics are concerned by INSPIRE. Hence, the results of official statistics always have at least an indirect reference to a specific location or geographical area. Data sets from official statistics are in principle concerned by INSPIRE if the following three conditions apply. The related statistical field is mentioned within the annexes of the directive. The data set is the reference version, and the data set is checked to be not confidential, which at the end means the data are already published or prepared for publishing. Regarding data modeling, the theme population distribution demography defines the prototype for official statistics. See, for example, the following excerpt of the technical guidelines on the theme population distribution demography. The list of domains contains themes that are INSPIRE themes by their own. But in the context of official statistics, the corresponding data have to be modeled in the same way as the data on population distribution demography. I remember many discussions about this issue 10 years ago and in the following years. In my opinion, it would have been better, and many misinterpretations would have been avoided if the theme population distribution demography had simply been titled official statistics. The theme statistical units, which for statistical purposes extend the theme administrative units, takes a special role, because it's not about subject data, it's about geometry. However, in Germany, the difference between administrative units and statistical units, as used by the official statistics of the Federation and the federal states, is not very large. There are only a few statistical units on NUTS 2 and possibly NUTS 3 level, which are not administrative units as well. In Germany, the official statistics cooperates with the National Mapping and Cadastral Agency to fulfill the requirements of INSPIRE concerning statistical units. The statistical offices have decided to, in Germany, of the Federation of the federal states, have decided to tackle the challenges of INSPIRE in common and to develop a joint strategy. The INSPIRE Discovery Service is centrally realized by the spatial data catalog of the German SDI. Hence, the metadata only have to be prepared for harvesting by the central catalog. The interface to the central catalog is provided by using the software GeoNetwork as metadata information system. The implementation of the generic solution is based on the following principles. First, data supply for INSPIRE is completely integrated within data supply for the German SDI, whose architecture fully takes account of INSPIRE. The information databases, Genesis Online and Regional Database Germany, are the primary data sources for the publication of regional statistics. Each so-called publicized table provided by these databases is defined as a predefined spatial data set. The named databases of I have to explain the acronym. The acronym Genesis means, Genesis is an acronym for Common New Statistical Information System. And both named databases are based on the same software, on the same technology. Genesis Online is hosted by the FSO, and the regional database is hosted by the office in North Rhine-Westphalia. A publicized table is a kind of a database view. And now I also can define regional data. Regional data in the sense of this presentation are the data in these databases. But these are data about administrative units from the municipality level up to the level of the federal states. Selected tables from the regional database Germany are classified as Inspire relevant. Currently, 73 tables are Inspire identified, covering the following statistical domains: demography, buildings and housing, education, health and social statistics, tourism and manufacturing. View and download services as well as metadata on data and services are generated in a generic way for each publicized table. To satisfy both the goals of the SDI of the Federation as well as the goals of the 16 federal states, for each table, metadata and services are generated once for the complete data set, and moreover, for each data set restricted to every federal state by selection via the regional code. In general, the output is based on the Genesis object model for data and metadata. Any desired XML scheme can be derived. The metadata are mainly generated from metadata already existing in Genesis, respectively in the regional database. The view services are realized by using map server functionality. The data format Genesis XML is used as interface format. The download services are realized as predefined atoms using Genesis web service functionality. Concerning Inspire requirements on availability and access speed, all of these resources are cached and automatically updated in a daily or weekly period, if necessary, if the data are updated. I've finished with an example. For the example, I use data from Genesis Online. The data are not Inspire identified. The reason is what I want to show is fully implemented in Genesis or for Genesis data, but is not so far for data in the regional database. We are working on this issue. I want I want to use the link. It's possible?
I don't think so. I'm not sure that we are connected to the world.
In the other conference room it functions.
Okay, try.
I'm sorry, we're in the wrong room.
Just put your finger on it, and if it works, we are happy.
With this link, we will get the table and the database. Okay. The uniform resource identifier of the data set is in the next row. Of course, this is an identifier in the SDI world for the table. It's important for the data service coupling. And the two links I noted are interesting because the links are at first are URIs, not URLs. They become URLs by the redirect functionality of the registry of the German SDI. This redirect functionality allows us to define user-friendly and stable links for the services. Sorry. You only have to know the namespace of our data and the code of the table in the database and the code for the regions covered. 00 is the code for all federal states. 08, for example, is the code for Baden-Württemberg. I can't use the links now, but believe me, with the first link, you will get the get capabilities document of the view service, and with the second link, you will get the service feed of the atom feed. Okay, the corresponding map is, of course, not very impressive, but I want to draw your attention to the legend. It's a little bit small, but the legends show you that the data are automatically referred to the surface area of the region to be categographically correct with the map. Thank you for your attention.
Thank you, Olga Heitsch-Riske. Again, time for 1 or 2 questions. Then, please, but wait for the microphone.
Thank you very much, Hannes Reuter from Eurostat, and I congratulate you to your excellent results. And I think we hopefully over the next couple of years we see more of this kind of implementation in the different national statistical institutes, because this will bring the whole, let's say, statistics and Inspire community closer together. Thank you.
Thank you.
Well, it's just one more applause. When Eurostat is happy, that's even more important than the audience. So, more questions? Yes, in the back, please.
My name is Pieter Bresters from Statistic Netherlands. And I was wondering, could you tell me why you did not implement a WFS? Because I saw you only implemented an atom feed for download services and not a WFS. Is there a reason for that?
I think it was easier to do. And it's an Inspire compliant solution, as I know.
Netherlands accepts the answer? Partly. So, okay, you may meet again for discussion. Well,
I think not the whole work is done yet.
Okay, thank you very much. And we switch to the next presentation. Can you please start it? From Christine Nayar, Switzerland, right in the center of this session, as in the center of Europe. And as explained before, Switzerland is not a member of the European Union, but a very active part of the Inspire process. Likewise, Norway. So whenever we talk of Inspire, we should not think just of the European Union, but it's other European countries involved as well, even if they are not forced by legislation. So there is more reason to do Inspire than just legislation. Please.
Thank you, Mr. Ullert. Bonjour, messieurs, mesdames. Good afternoon. My name is Christine Nayar. I work for Swiss Topo, and I would like to welcome you to my presentation, Switzerland Towards Inspire. I will give a very brief introduction to Swiss Topo and the situation in Switzerland. Mr. Ullert has already mentioned one of the aspects. And then I would like to introduce a feasibility study we've been doing at Swiss Topo concerning Inspire and ELF and the results of this feasibility study and a conclusion. So, Swiss Topo is the Federal Office of Topography of Switzerland. Its vision is geoscience for a changing society, so it features itself as a modern technology-oriented office. And it is not only a coordinating body, but also produces quite a large portfolio of national maps and spatial data. So there is also some in-house production here. But also it has a legal mandate for developing, coordinating, and operating the so-called federal spatial data infrastructure, which is based on a Geoinformation Act of 2007 and enables an easy exchange and wide use of spatial data, and defines 354 basic geodata sets. Now I will come back to those 354 basic geodata sets. They're quite important for us because they have certain requirements. One is that they must be described by conceptual models and also by standardized metadata, and you need to provide view and download services for most of them. So where are we currently in Switzerland? We have 71% of all the basic data models modeled, ratified, and published in the model repository. 57% of these basic geodata sets are offered by view services, another 53% by download services, and 86% of the metadata exist and are searchable in our metadata application called GeoCat. So when we come to the federal spatial data infrastructure, we have a viewer called MapGeoAdmin. Here there are 600 information layers and about 120,000 visitors daily. So as you can see, as a conclusion here, that there is an up and running existing infrastructure, probably rather successful for a small Switzerland. And so we don't start on the white sheet here with an SDI. So now what is the relationship Switzerland Inspire, or Swiss Topo and Inspire? So Swiss Topo has been participating as an observer in Inspire since the very beginning, and Swiss Topo also provides the national point of contact for Switzerland. So it is important for Swiss Topo to be part of Inspire. Also, there is very clear and not debated a strategic necessity of participating and contributing to an international geo-world. Nevertheless, Switzerland is not member of the European Union and also not member of the European Economic Area. There are some contracts with the European Environmental Agency, though. So, as a conclusion, there are no legal obligations to implement Inspire. There are certain obligations towards the European Environmental Agency. Having said this, last year, strategic goals were defined by Swiss Topo until 2020, which state that Swiss Topo would like to have their spatial data and products to adhere to international requirements. And here is an excerpt of the strategy, which is quite important for us. So Swiss Topo wants to improve the usability of its data and products and provide data and products that meet international requirements. Now, based on this strategy, it was possible for us to start this feasibility study, which we started last August, and selected 3 test data themes: administrative units, geographical names, and buildings. And the main goals were here to, in general, see what does it mean actually for, first of all, Swiss Topo, but second of all, the federal offices, if we would implement according to Inspire and ELF, now ELS, requirements on a technical, on an organizational, architectural, but also on the know-how basis. So here the more detailed goals on the slide. So we compare requirements. We have to map all our basic geodata sets to the Inspire themes. We have to implement the semantic and syntactic technical compatibility. And we have to determine the time and the costs which it would take. And also, which was quite an important process, the architecture of the existing architecture and verify the existing processes. The main challenges here were actually the building of an internal awareness within Swiss Topo. But at the time, which has changed now, there were various Inspire validators with different error messages. This is now a very technical level. And it was not always very easy to interpret the varying messages there. And therefore, I am very thankful that the new validator is being worked on now that should change the situation there. And as I said, we had to extend a running infrastructure. So what was our approach? First of all, we had a bit of a theoretical work to really go into the depth of all the technical guidelines and the implementation rules and compare them to the Swiss standards and the Swiss rules and regulations, and do the mapping between the Swiss basic data and the Inspire themes. And then we did a proof of concept where we took the 3 themes and actually did the transformation, the configuring of services, all the technical issues that have to be done, the metadata, of course, too. And there we could also verify the proposed technical architecture, and then could actually assess the costs based on the 3 data sets that we had used for the proof of concept, but also extrapolate based on 3 different use cases that we defined to all the basic geodata sets for the federal offices. To do this, we had to have some clear requirements. One of them was that we really wanted to use and reuse our existing models and services in our current infrastructure, and stay as close as possible to our existing infrastructure, and recycle processes, mainly processes, wherever possible. Also, we wanted common solutions for Inspire and ELF-ELS, and it was also important to reuse the same conventions on all organizational levels, for example, IDs or namespaces or coordinate reference systems. And then something which was important for Swiss Topo internally, that we work with one server, which is called map server, and we did not want to extend this map server. We're working with map server, and that was it. And our national data models, as you've seen, 71% have been already established. Were not supposed to be changed at the moment or extended to Inspire, but we needed to map these to the Inspire models. So you understand the general framework. I wanted to show you this slide, and here a couple of results, and maybe also at the same time issue. Here you see on the left-hand side the Inspire theme, and in the middle are the Swiss basic geodata sets. It doesn't matter if you don't understand the names. The main idea is here that, for example, for transport networks, we have a one-to-N relationship. I'm sure you have that in your countries too, that you have one Inspire theme and various national data sets which could correspond to this Inspire theme. Now also, you see that the Swiss TLM3D, that's the Swiss Topo data set, and now all the other data sets which are listed here, they have all other federal offices who are responsible for that. So if we want to harmonize this into one transport network data set, or the question is actually, do we want to harmonize it all to one transport data network service or data set, or do we want to provide each office their own? These are a couple of organizational questions which belong to the technical discussion here. And you can see at the end there's the use cases. We define different use cases, and this is how we extrapolated the costs and the time. So, for example, transport networks was allocated to be a maximal use case of 8 days here, but I will come to that. So the results is, in average, once you have the basic infrastructure running, you need for each new Inspire theme to configure the spatial, the services, the metadata, and all the other configurations that have to be done around. Also the transformation, of course, of the data into the Inspire model takes 1 working week. This corresponds to the average use case. If we wanted to do all the annex themes where the federal government is concerned, we need 112 days. If we look only at Swiss Topo, then it would be 65 days. And for the basic infrastructure, we need another 20 days to get it all automated and so up and running, and a yearly maintenance of about 7 days or 2,400 euro. So you see, it is not crazy amounts. it's not impossible on the time level. And you can see that we could also find that the technical and organizational feasibility can be provided. Also the know-how at Swiss Topo, we like to do as much as possible internally, is basically there. There are some organizational issues that have to be clarified, for example, these one-to-N relationships with the other federal offices, but in general, it is possible. So my conclusion is the path for Switzerland to inspire is open in terms of feasibility, technical and organizational. The costs and time have been quantified, and it's clear how much has to be invested. Swiss Topo wants to be active in the spatial community and participate, and we do not want to be the famous hole in the map. But there are some questions too. One of the big questions is, will these services really be used? So we want them to be used. If we invest, we want them to be used. So this was the big discussion, and therefore I think this is also something that will be closely monitored. How much are these services, these components used? Thank you.
Thank you very much, Christine. From your figures, I can already say that your office is probably more efficient than VKG in Germany, but I won't comment on that anymore. The questions are to the audience. Other questions? So if no, then congratulations to Switzerland, and many thanks that you participate in the exercise. Christina has mentioned the ELF project and the ELS project. I'm not sure that anybody in the audience is aware of that. That is a project by Eurogeographics that unites all the national mapping agencies in Europe, and they too make efforts to implement and create pan-European data sets which are compliant with INSPIRE. And many experts are involved. It's Switzerland involved, it's France involved, almost anybody. And it's a common exercise that should push INSPIRE as well. But even in Eurogeographics, we are not yet sure on the users. So still no questions? Then thank you very much for Christina.
Thank you.
And we switch to the next presentation, which is from Dejan Georgic from the State Office for Spatial Infrastructure and Land Development in Baden-Württemberg. So he will present some of the implementations that his minister has announced in the plenary session in the morning. Welcome.
Thank you for a very nice introduction in my presentation, and for a very nice pronunciation of my surname. That doesn't happen very often. Yeah, so I really appreciate it and give it credit to you. I am working for a competence center as the Baden-Württemberg, within State Office for Spatial Information and Land Development in Baden-Württemberg. Today I'm going to point out a few challenges, very common word for INSPIRE, and also what is important. I will give a short summary of solutions that we have for the problems that I will mention in the presentation. INSPIRE is a really complicated thing, so I will just try to focus on one specific thing. It's our quality management system that we are using in order to overcome those problems. Like any other quality management system, the main output is a report which has to be delivered to the user in order to fix some things, to improve some things, and some of them are listed on the slide. that you see on my left-hand side. And for example, we are monitoring metadata harvesting processes that are based on constraints like a keyword, which is very usual trigger. Also, we are working on a fully automatic generation of a monitoring report that has to be submitted to the European Union. And also, we are doing a quality management of the metadata. One example is to check if there is if there are non-unique resource identifier in our catalog. I will concentrate on the first 3 bullets today, but our quality management system is not just about those 3 things that I mentioned before. It can also generate a report concerning implementation state in our federal state. And also we are doing a quality management of the metadata, central components, and SDI services. Before I start with the problems and challenges, I think it's very important to explain our organizational structure, because sometimes organizational structure also influences how also influences technical solutions and other component of SDI. Quick overview on a European level. We have a decentral organizational structure on a national level. In Germany, we have also decentral organization, and as you all know, Germany is consisted of many federal states, and that's why we are having our federal state SDIs. So few reasons that are SDI relevant for choosing a decentral organizational structure are, for example, we had organizations that already had some kind of spatial infrastructure before Inspire came into play, services, metadata catalogs, and also those organizations and public authorities had different levels of knowledge regarding an SDI. So it was a good approach to build up on the existing knowledge and try to develop a infrastructure in a decentralized way. On the next slide, I will not go too much into technical details, but I will just try to explain how does it work in a very generalized way. So we have a different catalogs on a federal state level. Then those catalogs are harvested and then imported in a metadata catalog SDIBW. Then XMLs are imported in a database where some processing is done in order to store data in a convenient way. And also there are some APIs which we are using in order not to reinvent the wheel. So, for example, the test suite API from Germany, then we are making a request, firing a request against the database, XPaths, and SQL statement, and then the system is providing a file, CSV file, which is then delivered to the user, which can later generate a report and fix or improve some things that has to be done. So as I mentioned at the beginning of my presentation, I will state a few problems and give you solutions for that. In Germany, the open data community is becoming bigger and bigger, and that's why there is a need to store the data or to make data available to the users in one portal, which is government data portal. But the data are not automatically there. They have to go through this chain in order to end up on the right way. So if you pay attention to the constraints, there are several things that are checked before the XML file is transformed into JSON file, because this is because government data portal is Baden-Württemberg. But before this happens, some things has to be proved. For example, is a keyword existent, if both metadata are ISO valid, if we have a license in JSON notation, if a data service coupling is existent, and if this is not done, then in the end, the open data metadata or metadata that is describing the open data geodata will end up in a government data portal. In order to fix this problem, we are using a log file from SDI Germany, where all metadata inside the national catalog are provided, and the information is also provided concerning those constraints. And we are importing this log file. Then we have to filter the data that we need. Then we have to check if one of those constraints is not fulfilled. Then we have to provide a report to the specific organization which is stated in a metadata for the geodata and also for the service. In this way, we again didn't reinvent the wheel. We again used the existing report, and we provide the report which is relevant to our user. And monitoring report is also a thing that has to be done on a yearly basis, so it makes sense to make this process automatic. And the basis for that is metadata. But as we know, not all metadata elements or not all information which is needed is not encoded in the XML itself. For example, we have some requirement from Inspire, like actual area, relevant area, and so on. But we also have the requirements from our spatial data infrastructure on a national level. So the first step is we often forget the point that a lot of organizational work has to be done in order to make a foundation for technical solutions to work. And the first step is to define those elements in a metadata profile, and also in conventions regarding metadata. And then when this is done, XMLs and metadata can be used to generate a report, which can later can be submitted to the monitoring register. The third and the final problem is I chose very simple problem to understand the problem. If you have two namespaces which are unique, and if the local IDs are also identical, then you don't have a unique identifier. So what are we doing? We are checking if there is some metadata in our catalog which doesn't fulfill this uniqueness requirement. And then we are also generating a report which gives some useful information to the user, which can later identify not the user, to the SDI partner, which can later identify the problem and solve the problem in a convenient manner. So the solution is again a report which has to be considered in order to solve some problems. On this slide, I would like to give a quick summary of the main points that we have discussed today. Our spatial data infrastructure is decentrally organized. Many organizational agreement and also technical solutions are necessary to make SDI to work, but one important thing is we need to make it work at the same moment. If we have a technical solution which is perfect, all functionalities, if we didn't consider the organizational structure, then it won't fit again to the infrastructure. That's why I think that quality management system is a very important thing, and it cannot be considered as an isolated component. It has to be an integral part of an SDI, of one SDI. With this sentence, I would like to conclude my presentation, and if there are some questions, I will be very happy to answer them.
Thank you, Dan, for putting our focus on one aspect which is somewhat neglected in Inspire so far, the quality management. Are there questions from the audience? Please wait for the microphone.
Thank you. Thank you for your presentation. It was very interesting. I would like to know if the Inspire validators provided by the Commission are part of your quality management system, or if you use only house-made tools.
What we did, we tried to use the APIs that are available to to validate our metadata. So my answer is yes. We have an information from Inspire validator. Like this is one column where we have information if it's valid or if it's not valid. So the test suite API on a national level is considered. We also have a metadata validating service that we are using to check our specific requirements which we defined in our metadata profile. And on top of that, we are also checking if our metadata is Inspire conform, which validator also gives this answer. So yeah, we have it.
Thank you.
Any more questions? Please, just hand over the microphone.
You said you in the generation of the report, the monitoring report, you said you didn't calculate the actual area from the metadata.
I said that we are considering this information in our metadata profile. That this information can be encoded in XML. We are currently working on that because it's not very easy to find a specific element where data type is okay, and okay in this case it is a character string, but we also have to find a proper element that fits to that. Keyword is one solution, but not very nice solution. But I I think this has to be done, and we are currently working on that, taking a look at the ISO profile and try to find the correct element for that. Not easy, challenge.
It is not.
Yeah.
Which reads the title of the session, Challenges.
I've tried to provide a few solutions, but I think that we will always have the challenges, and it's very important to have the tool that is upgraded and which is constantly improving in order to deal with these challenges. Because I think it's too optimistic to say we won't have challenges in 5 years. I think that quality management system can help us to deal with those problems.
Well, thank you very much again.
You're welcome.
We turn to our last speaker. Welcome Dominique Laurent from the National Geographic Institute of France. And she has important roles with the INSPIRE process and with your geographics as well. You will find her at several places in the conference with presentations, but each presentation is to different topics. And with this presentation, she highlights the redesign of the French topographic database.
Okay, thanks Andreas for this nice introduction. So I will present the context rather quickly, explain the main topic, how INSPIRE has influenced us, and some conclusions. Very classical presentation. So the general context, we talk about our database that is called BDUNI version 1. It's our current internal production database. It's about large-scale topographic database, around 10,000 scale. It's our main data in IGN. And we have a project that is called, very logically, BDUNI version 2. It's the redesign of the data specification, but mainly of the data production process. However, in this presentation, I will talk about data specification. And this specification work took place last year. So what are the objectives of this new product? We have many things that are linked to the process itself. It's be more collaborative, be more reactive, quicker updates, it's the main reason. External products also closer to our production database. We have also some demands about the content itself, be closer to INSPIRE, be closer to MGCP for defense needs, and fulfill better other user requirements. And we have even, I will say, some contradicting requirements, such as being both simpler and richer. The methodology for the working group, we had a working group to prepare this new specification. As entries, we have mainly the specification of our current product, version 1. We have the user requirements coming from marketing surveys. We have the MGCP requirements, and regarding INSPIRE, what we have really is not the INSPIRE models themselves, but rather the matching tables exercise and the difficulties discovered during this matching table exercise. And from this, we have the specification of our new product as output. And the purpose is really to make the transformation to INSPIRE easier and better quality. The INSPIRE concerned themes, it's mainly administrative unit, geographical name, transport network, building. There are some other themes that are also available at large scale, but that have been considered in other dedicated products with the external stakeholders and different methodologies. And we have also the theme about governmental services, but it was not too much considered because we have electric lines and we thought that it's more about the net utility manager to deal with it. And regarding governmental services, there were no need for change in a way. So the INSPIRE influence, it's at different levels. the first reason is to avoid what I will call wrong transformation. Let me give an example. It's about the railway station example. In our current product, we have a point of interest that is outside the network. We have the railway line, and the point of interest is not on the line. It's outside. And in InSpy, you can have either a railway station area or a node. So in the matching table, we have decided to make the correspondence between the point and the node. We know our points are not nodes, but if we don't do this matching, there is key information missing. So we could not escape to make the transformation, even if we perfectly know it's the wrong one. So for the next, for BDUNI version 2, we have decided to capture railway station as areas. Maybe it's not so perfect geometry, but at least it will fit with the definition. So to have something like this. Another example is to avoid loss of information. Let me give two cases. For instance, for vertical position, we have more information than InSpy, but we have what InSpy expects. We have the levels, and InSpy only wants on ground, over or under. So in this case, we do nothing. We have what InSpy expects, it's enough, no action. But in some other cases, it's more difficult. For instance, once again, it's about the railway, the design speed. What is expected by InSpy is the design speed itself. What we have in our current product, it's just a distinction between ordinary trains and high-speed trains. It's what we have. And what we are able to provide at the moment is nothing. Because we have an idea of this high-speed train, but I think we have the minimum speed, and InSpy wants the maximum one or the opposite, so we cannot do any matching. So in this case, it justifies some action. So at the moment, it's not nice, so we have decided to include the design speed information in the specification of our new product. And it's not even enough to make it in the specification. You have to fill the information. So we are going to struggle to get partnership to fill this information. Another example is to make transformation easier. For instance, in the administrative hierarchy in IGN, to make it simple, we have one feature type. It's the municipality with its geometry, its code, its name, and this feature type is carrying all the attributes of the upper level, of the arrondissement, département, région, and in a way it's up to the user to construct the other levels. Because it's large-scale data and people are mainly interested in the lower level in the municipalities. And for InSpy, you need a feature type for each level of administrative unit. So in the current matching rule, we have to create new feature. It means create the geometry by merging the geometries of the municipalities, and maybe more difficult, providing unique and persistent identifiers. So it's feasible. We have tried to construct an identifier based on the national code of the municipality. As we have many specific cases in our administrative hierarchy, the transformation rule is rather complex. And it makes also some difficulties. The transformation is complex, and it's also some confusion between external identifiers and thematic identifiers. So the decision for new product is to create really a feature type for each level of administrative unit and to manage in our production database this unique and persistent identifier. It's really difficult to make this especially persistent identifiers in transformation rules. It's easier to be done in the production base. Another example that maybe is the most interesting one is about pumping up our data model. Generally, it's the opposite question. Everyone is talking about flattening the InSpy model. And what we have decided to do is maybe to do the opposite. We have a lot of information related to geographical name in our source data, mainly because a feature may have several names, and these names have some information why they are different, a little as in InSpy. But currently, our solution is quite different, as we have table-based, and in a table you can have only a limited, for instance, number of names. We put everything that has a name in a single feature type and with a point geometry, and the result is that the names are allocated to point instead of being allocated to the real feature that might be, for instance, an area or a line. So it's really not user-friendly, it's not in line with InSpy, so we have tried to improve it, and we have decided to be close to InSpy. In InSpy, you have this geometry that may be anything, a point, a line, an area, and as many geographical names as you want, with some information describing the name as the language, the nativeness, and so on. So we are going to be very close to this, really going from a table structure to something more hierarchical as in InSpy. And we think about using some JSON attributes, and maybe we will have need to develop new tools to capture and manage this kind of attributes. So we have them in the specification, but it has to be tested. So maybe it's not very spectacular, but I think it is in principle. We try to have something hierarchic in our production database. Another case, but that is quite more simpler, it's just enriching our data model. For instance, for buildings, there are some attributes that are required by InSpy, such as the current use, the date of construction, the number of flow, number of dwellings, material of roof, material of structure, and they are required by InSpy, but they are required also by our users. So it's a reason to try to include them in our product, in the specification, and once again, try to find ways to fill these attributes. So for buildings, we have decided, yes, to include them in the data model and try to get information. It's not so easy because it should be done with collaboration with Cadastre, and there is some issue regarding the links, the technical things, but I think this should be rather easy, but more difficult, all the privacy and the issues, because it's declarative data, and I'm not sure it can be used in an easy way. So some learnings and conclusions. You may wonder about our modeling approach. Have we used the InSpy models? Not at all. And even we don't even make any model at all. We have not worked with UML, we have worked with Excel tables. The work was really about the content, not about modeling exercise. And why? Because it was not in the missions of the working group. Maybe it's not so much in the IGN culture. We know UML, but it's not a reflex. It's not we don't see it as a requirement. And also our models were rather simple, so maybe the graphical help of UML was not seen as so necessary. But it's not the end of the story. We can have UML models in future. Regarding InSpy, we need flexibility. Of course, InSpy has significantly influenced the design of our new product, but there are still lots of differences, discrepancies. For instance, the structure between the themes, the sub-themes. InSpy ferries are in water transport. For us, it's the continuity of the road transport. We don't have exactly the same features, the same attributes. We have not tried to align everything on InSpy. We are adopting InSpy to avoid wrong transformation, to ensure minimum quality of InSpy data, and when InSpy was seen as a reasonable constraint, for instance, the railway station. And InSpy was also maybe more positive in helping us to push some user requirements. For instance, InSpy seen as an opportunity to enrich the building, to make geographical name more efficient. But I must confess, we have not always adopting InSpy. It was not the main driver. Our main driver was the user requirement, and I will say the main starting point was the old product, not the InSpy data models. And we don't see any need to adopt InSpy natively in production if the transformation don't raise issue. If we can do the transformation in an easy way, there is no need to change anything. Another reason is that InSpy is not always seen as good practice. The typical example is about transport network. In InSpy, the transport have feature types attached by linear referencing to the transport object. In our source data, they are attributes directly carried by the transport object, by the geometry. And it's easier to manage in production, and it's also easier to be used by GIS. So really, we have not adopted the InSpy modeling approach because for us it was no improvement. It was even the opposite. Another reason why not always adopting InSpy is that we have to take into account the production constraint. We don't make a new specification just for making specification, but for making real data. So InSpy doesn't mandate the capture of new data. Nevertheless, we have tried to enrich our new product, but we have limited this enrichment to what is considered both as useful and as more or less feasible. It has also conducted us to have more flexible specification. In our current product, we have more or less things that we think we can fill the attribute, we can fill the feature type. We try to be exhaustive. In our new product, it will be a little more flexible with core content that we ensure some quality and something more extended. It is included, but we know we have to struggle to fill the data. And the next steps, it's the validation. In a way, we are not going to have our specification validated by users. We are going rather to make some prototype data and to have this prototype data validated by the users. So the validation will be done not on the on paper specification, but on sample data. We have to work on external products, and I think for InSpy, we will have to make new matching tables. We have not made this matching table from the new specification at once, so maybe we will discover new issues. It's not guaranteed with this new product. We have solved some issue on one hand, but we may have invented new ones. We have to check. So many thanks for your interest.
Thank you very much, Dominique. It's interesting to hear how somebody who knows Inspire very well reflects that experience on the national data. Are there questions from the audience? Please, just wait for the microphone, first in the back, then in the front.
I have a question regarding the reference scale of the data sets, 10,000. So I'm just wondering, why do we have to represent for 10,000 every dwellings, or actually every house?
Yes.
I mean, and also the level of details, like, I mean, I've learned from my national experience when I was involved in creating technical specification for topographic map at scale 5,000, that all these buildings are more generalized. So actually, you don't have to represent every building on the map. So I'm just wondering. Yeah.
We have to represent each building. We don't have to represent each dwelling, but to give the number of dwelling as attribute, because it's important for the users.
I see. Thank you.
Please first in the front, and then okay, just.
It's quite interesting that you design a new product, and in the fact of the buildings, you need additional information. How do you get this information?
We will try to get it from Cadastre, but it's not so easy because cadastral data is really not open data, not only free, but there are a lot of accessibility issues and things like this. So we have to negotiate not only with the cadastre itself, but also there is an organism in France protecting data privacy. So there are some negotiations to be done to get this data in a way as core data on buildings, because it's data of interest really for many use cases, many users, and it's quite a pity that it's not easily available.
It's not really a question, but more a comment. From the point of view of the professionals of transport, and in particular road network management, the linear referencing is very, very important. So I'm not sure that the linear referencing in Inspire is not a good practice from this point of view.
We had this discussion also, and our feeling is that in a way we need both. For GIS application, for instance, just for mapping, it's very important to have the attributes as direct the properties as direct attributes to make these things working easily on GIS. And on the other hand, maybe for more business attributes, you need also linear referencing to attach in an easy way these business attributes to the network. But in a way, it's a strong issue about how to make these two reference systems work together, because there are the two needs. Some users need direct attributes, some need linear referencing, and how to move in an easy way from one system to another, it's really an issue. And I will say I am also sharing InspireCan, Knowledge Exchange Network of Eurogeographic, and it's a topic we have in mind maybe for a future workshop about how we can make these two reference systems work together.
Okay, so thanks again to all the speakers. Thanks to the audience for staying with us until the very end. Thanks to the conference team, and I hope you enjoyed the first day of the conference, and I wish you a nice time in the city in the evening. There are plenty of restaurants, very good restaurants, very nice atmosphere, and please feel well in France. Bonsoir.